Hello everyone, welcome back. You probably just came from watching the other video. I just wanted to get a chance to show everyone exactly what we did in class. So, for instance, if you're working on Geogebra at home, I want to show you how to set it up, and then you can take a look at the other file posted if you wanted to just see a complete version. If you wanted to set it up, first I want to input a function. I'm going to call it f of x because we're working with Geogebra, and I'm going to call it a times b to the x. We're going to be a continuous function, and I'm going to need to create sliders for that. So I'm going to create those, and then I'm just going to go to object properties. For a, I'm okay with the increment going from negative to positive. We're just talking about those starting values. And the increment, I might choose something like 0.01. That's fine. And then this b, I want the object properties. I want to go in here. Let's just use numbers that are positive right now. And again, we'll go with 0.01 just so we can see a different transition as we go. And the other thing I want to do is I want to compare that, which is going to be an exponential function, but I want you to notice something. It's in the form of an exponential function, right? A times b to the x. But why is it not, as you can see, curved like we normally see an exponential function? Well, the reason is because our starting value, a, I want you to take a look, it goes up and down as we shift. So this is our initial value, and that changes the initial height of our function. And the thing we're multiplying by repeatedly, the part of this that makes it geometric, is a 1. So whatever it is, we're just multiplying by 1 at each term. So it's just going to stay at the constant rate. But you'll see as soon as I moved it just a little bit, you can already see that that line is actually slanted. And if it was to move a lot, you can see that it's taking that exponential shape that we would expect. So I'm going to put that back down a little bit. It's about here. And now I want to compare it to the other function where I want to compare that to just a linear function. So I'm going to say g, right? I'm going to say g of x is equal to, let's say, b x, because I want to compare the arithmetic part here to the geometric sequence that's created by this a times b to the x. And the last thing that I want to do is, for the sake of comparison, let me make one more slider, because I'm only really interested in integer parts. So I'm going to call it n, and this is going to be my integer intervals that I'm going to use. I'm not going to worry about every possible little x that it could be. I only want to use the interval part. So I'm going to n is about 0 to 100, and I'm just going to worry with integers that are positive from 0 to 100. So I'm going to go with increments of 1. So I have my 3 sliders now. And my last thing I want to do is I want to make a line x equals 8. X equals to n. So that as I move n, I can compare it at different spots. I can compare n at 0. I can compare it as I move along. I want to get out of slider to move. Be careful as you clicking on things. I want to be able to move n along, and you can see that I'm looking at each integer. And the reason I want to do that is because I want to compare the growth. So what I'm going to do, if you were doing this at home, I want to take a point, but I don't just want a point, I want an intersection point, because I want to know at what point this line is intersecting with each function. So this gave me a new point. I'm going to rename it. I'm going to call this one f because I intersected that one with f. Okay, and I'm going to call this, I'm going to do another intersection point, and I'm going to call this one, yes, you guessed it, G, because I'm intersecting it with G. And the reason I want to do that is because I want to look over here. I want to focus at the difference in these y values as we move along. Here, this f, remember f is going to be representing our exponential function, and we're using intervals of integers, positive integers from n equals 0 to 100, and we're also going to look at the arithmetic sequence created by the function g, which in this case is 1.08 times x, but we're looking at only intervals that are positive integers. Notice that when we look down here, we see that the linear function, the red function here, g, is greater than the exponential function after 1. So initially the exponential function is greater because its initial value is greater, And then we observe that shortly after the linear function, if you look, we follow g, is greater than f. And it continues that way. And then we head a little bit off screen, and let's head back over here to track our functions, right? We see that by the 8th number in the sequence of each, the function g is much greater. It's at least 4 times greater. And if we continue on, it continues for a little bit. Now at the 10th, we're 10 times greater nearly. And as we go, though, we're going to start to see that shift happen again. And now over here, you might notice that we're starting to pick up. The gap is actually getting smaller in between. And I don't know what point you noticed it, but the b has surpassed it. Because the b value is 1.08, the function f is now much greater. And if we keep going, this rate of growth is going to continue rapidly. And the reason for this slider that I created is because I wanted to use a and b values, because then we can use this to help us create representations for the later problems. For instance, if I was to change this b to be a 2, let's just look at this. If b was a 2, and our initial value of a was even something very, very small, look at b at 2. And look at a when it's very small. Just watch. I just want to observe. And if you're playing alone at home, already, because b is 2, by the 10th time, we're well over the size of the linear function. If I could zoom out a little bit, I'll show you. You can just see the rapid growth of the exponential function. It's staggering. Look, by the 25th, it's already well over 300,000. That's into 3,355,443. And as we continue, by the time we get to 100, it's absolutely massive number that it couldn't even fit in the GeoGebra screen. So take a little bit more time to play around with the exponential function, and hopefully it will help you complete the rest of the homework assignment.